Welcome to Crypto 101. This is Module 2, and let's go ahead and get you started. Let's start right away. Here we go.
Lesson 4, what is a smart contract? Lesson 5, what's the difference between 2.0 and Web 3.0 development? And Lesson 6, how does blockchain technology improve payments? Now for Lesson 4, what is a smart contract?
Smart contracts are digital contracts that execute automatically when certain conditions are met. They were first proposed by Nick Szabo in 1994, but they didn't gain prominence until the release of the Ethereum blockchain in 2015. In the context of our community, smart contracts can build trust between traders, reduce costs, and speed up transactions. Smart contracts could be used to enforce a pre-established agreement around carbon credit usage within the community. For example, once a community member accumulates a certain number of carbon credits, like by planting trees or installing solar panels, 1 tokenized ounce of gold is granted from the community treasury to that individual's account automatically. A lot less bureaucracy. In another example, a smart contract could record the live temperature inside a milk storage facility. If the temperature exceeds a certain threshold, the milk could automatically become void for safety reasons. As all records are recorded onto the blockchain, where they cannot be tampered with by the milk supplier, the community has full transparency into the conditions of their milk. There's no need for a middleman to check the milk and approve the transaction. The smart contract does it automatically. Do you need smart contracts to build on a blockchain? Not always. The majority of developers don't need to write smart contracts to interact with the blockchain. However, some may need them to improve the functionalities that a blockchain offers, depending on which one they are building on. The XRP ledger does not have native smart contracts, but there are different ways developers can add these functionalities to it. Hooks. Hooks are small pieces of code that allow logic to be executed before and or after XRPL transactions. For example, if X occurs, then execute Z. We take a closer look at hooks in the intro to new innovations on the XRPL module.
That concludes lesson number 4. Lesson 5. What's the difference between Web 2.0 and 3.0 development?
Moving from centralized to decentralized. Building on Web 3.0 offers new challenges and opportunities that are different from those in Web 2.0. With blockchain technology, developers can create decentralized applications that are secure, transparent, and not controlled by any single entity. Web 1.0. Representing the first version of the Internet, Web 1.0 saw the development and release of HTML, CSS, and JavaScript. People could now get the information they needed with just a few clicks. Web pages were static, and there was little in the way of content contribution or user interaction, which is why Web 1.0 is sometimes referred to as the read-only web era. Web 2.0. The second generation of the web brought us social media, blogs, and other user-generated content. It became possible for users to create their own content and share it with the world, which is why this time is coined as the social web era. Web pages became more dynamic, and personalization became possible with the advent of cookies, which allowed websites to store information about user preferences. While users could now interact with content, they were still limited to doing so within the confines of centralized applications. Their data wasn't owned by them, and they had little control over how it was used. Web 3.0. The next generation of the web is being built on the blockchain. With blockchain, developers can create decentralized applications that don't require a central server or third-party service. This allows for a more secure and resilient web that isn't reliant on any single point of failure. And the apps share a common backend. Developers are excited about this new architecture as it allows ownership and tracking of digital items across distinct applications. Web3's decentralized application development. While Web 1.0 allowed us to read content, and the emergence of Web 2.0 allowed anyone to create their own content, Web 3.0 actually enables these creators to own their content. Web applications have traditionally been centralized. This means that there is a central server that stores all of the data and manages all of the computations. The client or user interacts with this central server to access the information or application. With decentralized applications, there is no central server. The data and computations are distributed among many different nodes in the network. Not only does this make the application more secure, since there is no single point of failure, but it also opens up new possibilities for how data is stored and shared, as well as how users can monetize their content. Popular use cases: payments, decentralized finance, gaming, NFTs. The emergence of Web 3.0 has led to the development of use cases that were simply not possible with traditional web technologies. Payments in decentralized finance, or DeFi. With blockchain, we can now send and receive payments without the approval of a central authority, like a bank or government. This enables peer-to-peer transactions that are fast, cheap, and secure. Blockchain has also enabled the development of decentralized finance protocols, which allow users to lend, borrow, manage, and trade cryptocurrencies without the need for a centralized intermediary. Gaming. Blockchain introduces a more decentralized gaming experience where players have full ownership of their in-game assets. These assets can be traded or sold on secondary markets, giving players real-world value for their time and effort. NFTs, non-fungible tokens, or NFTs, are unique digital assets that are stored on the blockchain. NFTs can be used to represent anything from digital art to in-game items. As such, they are changing the way we think about ownership and value in the digital world. How can my skills as a developer translate to blockchain Web 3.0? If you're a developer, you may be wondering how your skills can translate to the blockchain and Web 3.0 spaces. The good news is that there is a lot of overlap between the two, and your skills are in high demand. What programming languages are used in Web 3.0? The exact skills you need depend on the blockchain you want to build on, as well as the specific application you want to build. For example, if you're interested in developing smart contracts, you'll need to be proficient in a specific smart contract programming language like Solidity or Rust. Developing on Ethereum requires knowledge of its unique programming language, Solidity. However, if you're more interested in building decentralized applications or dApps, you can use a variety of programming languages to do so. A key difference between Ethereum and the XRPL is that the latter doesn't use smart contracts. This means that developers who want to build on the XRPL can do so with a wider range of programming languages. Key differences in development. Although they are different, the foundation remains the same. They are basically websites or apps on the internet. So if you know how to design a sleek website on Web 2.0, you're in a great position to do the same on Web 3.0. The front end will require the same skills and effort, but while Web 2.0 apps rely on centralized servers for the back end, Web 3.0 apps use an open public infrastructure as the back end. Other important differences lie in how data is handled. Authentication. Usually, you would handle passwords and login information on a centralized server. With Web 3.0, authentication is done using the same cryptographic keys that are used to send transactions on a blockchain. Data is stored directly on the blockchain and other public networks, enabling out-of-the-box interoperability. Traceability. Blockchain data is immutable, meaning every transaction is recorded and cannot be changed. If you're a developer who believes that there is a better, faster, more secure architecture for internet apps where users are in control of their digital property, Web 3.0 development is for you.
That concludes lesson number 5. Lesson 6. How does blockchain technology improve payments?
Enabling easy and reliable transaction validation. Blockchain is changing the way we interact with money and value. Just like in our community analogy, blockchain removes the need for a central authority to oversee how we transfer value. This means that payments can be processed much faster and at a lower cost. But what protects the money if all the code is open source? The value lies in public keys and private keys, as well as the digital wallets used to store currencies. These cryptographic inventions are a big part of the solution that enable anyone, anywhere, to hold, send, and receive digital assets and money at global scale. With the help of these cryptographic keys, payment instructions can be digitally signed. So validators in blockchain networks can validate the authenticity of transactions. Let's take a look at public keys, private keys, and digital wallets in more detail. Public key. This is a unique alphanumeric code that acts as your public address on the blockchain. It's like your bank account number. Anyone can see it and send funds to it, but only the person who knows the private key associated with the public key is able to move funds from it. Private key. Similar to a password, your private key is a unique code that proves ownership of your public key. It's what allows you to access your funds and make transactions. It's important to keep the key safe and secure, as anyone with access to it can sell your assets. Many types of private keys exist, including the following: 64-digit hexadecimal code, mnemonic phrase, 256-character-long binary code, QR code. The mathematical formula to generate private and public keys is open source. So how does no one else have the ability to create the same key? Wallets. A digital wallet is like a physical wallet, but instead of storing cash or cards, It stores your private and public keys. As such, your assets don't actually live inside your wallet, but rather on the blockchain itself. The wallet just provides a way to access your assets. There are many different types of wallets available, including paper wallets, desktop wallets, mobile wallets, hardware wallets. Each has its own set of features and security considerations. So it's important to choose one that's right for you. How is blockchain changing the financial system? Here are a few key ways that blockchain is changing the game for payments. Enter enka ando aichio. Banking for the unbanked. Perhaps one of the most exciting uses of blockchain technology is its potential to reach people who are unbanked or underbanked. These are the people who don't have access to traditional banking services, which often leaves them excluded from the global economy. With blockchain, anyone with a mobile phone can send and receive payments via their digital wallet. This is a game changer for the estimated 1.7 billion people who are unbanked and nearly 2 billion more that are considered underbanked. Higher speeds and lower costs. Traditional payment systems can take days to process international payments and can incur hefty fees. Blockchain-powered payments can be processed quickly and for a fraction of the cost of traditional payments. Increased security. Traditional payments can have data leakage and fraud. Information is kept on centralized servers, which means hackers have a single point of attack and are incentivized to attempt a breach. Information on the blockchain is distributed across a network of nodes, making it much harder to hack. Additionally, each transaction is encrypted and wallets can only be accessed with a private key. This increased security is a game changer for the payments industry, which has been struggling to keep up with the ever-evolving threats posed by hackers. These are just a few of the ways that blockchain is changing the game for financial services, with its potential to reach the unbanked, as well as its increased security and efficiency. It's no wonder that more and more institutions and individuals are turning to this innovative technology.
That concludes lesson number 6.
Congratulations, you now completed Module 2. The next module has the last 3 lessons in it, and if you'll tap the link for the next video will be one of the links at the top. The other link at the top is for a playlist that has all 3 modules in it. So, thank you for watching. I'll see you next video.